What's going on, guys? Welcome back to this video. Today we're doing again CA 2023 track. The challenge we're going to cover is getting started. In the previous challenge we covered questionnaire, and the questionnaire was a walkthrough on how to kind of analyze a simple binary by understanding the structure, whether it's 32-bit or 64, and understanding its basic disassembly code using GDB debugger. Today we're going to use get started. Now these two challenges can be a good start if you want, or if you are learning buffer overflows. So let's click on getting started, and we are given, as you can see, IP address and port. These will be used with netcat. We're going to connect using netcat to the IP address on the assigned port, and of course there are files to download. So let's go ahead and get started. So when we download the files, as you can see, we have these files, except this one. This is generated by PIDA. Ignore this one. Now we have these files. We have flag. Of course, it's not the flag for the challenge. And we have this directory and this binary. If we issue the file flag on GS, we get the type of the file. It's 64-bit, dynamically linked, and not stripped. And this is the hash of the file. We have also a Python script. If we take a look at the Python script, alright, as you can see here, it uses pawn tools. Okay, so basically, in order to use the script, you have to install pawn tools. I'm going to show you guys at the end of the video how to install pawn tools. Now then it imports the pawn library, and then it defines an IP address and port. So you're gonna have to change the IP address and the port with the corresponding IP address and the port given in the challenge. The next thing is, as you can see, we connect to the IP address and the port here, and then we craft a payload. As you can see, the payload is composed of A's, a number of A's. Now initially when you open the script, you will find here the number of bytes. It was actually not 32, it was 10 or 8. So I changed this to 32 bytes. And then as you can see, we send the payload using this command. And if we send the correct number of A's, we're gonna get the success flag. So for now, I'm gonna change this back to maybe 10. Alright, what about this one? If you go to G, these are the shared libraries, I think, used to, these are the shared libraries used to build this binary. But anyway, I don't think you need to interact with this binary. What you need is the Python script, and you need also to connect on this port, on this IP address, to interact with the binary itself. Okay. So NC okay. So we start from here. This is the stack frame layout of the binary. So first, as you can see, we have the buffer. It's 31 bytes. Okay, and then we have 8 bytes for the alignment, another 8 bytes for the target, and lastly we have another 8 bytes for the RPP and another 8 bytes for the return address. Now, may I remind you guys that all the time in buffer overflow attacks, our aim is to fill the stack with a certain number of bytes until we reach the return address. Once we reach the return address, we want to fill the return address with the shell code, or the actual payload that will be executed, or make the binary, or let the binary execute the shell code. The shell code will do multiple of things. It might do denial of service attack. It might give you a complete shell back to the system. It depends on the scenario, but here we're not going to explore the return address. It's not for this scenario. I'm just giving you this as a note. our job here is to reach the target here. So we have to fill these spots. Let's go down. So this is the start of the buffer. As you can see, we have indeed 32 bytes, and here we have 48 bytes. So each one of them represents 8 bytes, 8 bytes, 8 bytes. Now, as you can see, after we insert 4 A's, okay, the stack layout shows like this. As you can see, these are 4 A's. 1, 2, 3, 4. Another example was to show you here, as you can see, if we insert 4 B's. So 4 A's, 1, 2, 3, 4, these are the 4 A's, and then they inserted another 4 B's, 1, 2, 3, 4, 4 B's. So exactly they sent 8 bytes to fill the start of the buffer. But as you can see here, we need to fill all of these addresses, all of these bytes here, at least till this point, to be able to reach the return address. Okay, so basically that's how buffer overflow works. You have to overflow the buffer or the program above its capacity. So when you overflow the program, you will be able to reach a certain number of bytes, after which you will be able to reach the return address. Now, that's the assignment here. Fill the 32 byte buffer. That's the buffer of 32 bytes. Okay. Fill the 32 byte buffer, override the alignment address. This is the alignment address. Again, it's 8 bytes. And the target's dead beef value. This is the target dead beef value. Now, the main job of this challenge is to change this. But in order to change this, we need enough number of bytes. So here we need 32 bytes, and here we need 40 bytes. So what do? Let's go here. Use GDB on GS and pattern creates 32. So we generate 32 bytes. Let's take them. Looks like we have a problem in the connection again. Okay. So we insert the 32 A's. But we receive you failed. That's expected. We haven't filled yet the target here. So as you can see here, I just want to show you, we have successfully filled this buffer with 32 bytes. Now we need another more, right, to cover the alignment. Let's cover the alignment with more 8 bytes. So we get back here, pattern create, and we generate 40 bytes. So we take this and we supply it here. Now you failed, but there is a flag here. It's the correct flag. So as you can see, we have successfully filled the buffer and the alignment, but we did not cover it, or we did not fill the target yet. So we need another more 8 bytes. So we go back here and we generate 8 bytes. So we take the 8 bytes, we send this, and now let's take a look. And we successfully, as you can see guys, changed this. The target to change has been changed. Let's take a look at the difference. So this was a target to change. It was filled with dead beef. Now it is filled with our payload, as you can see here. So we have successfully filled the buffer, the alignment, and the target to change. Now this is the correct flag. Although it shows you that we failed, it's okay. That's the way to change the whatever it is, the target. Now if you want to overwrite this, you can do that. So let's do that. We need another more 8 bytes, which means we went around 56 bytes. So we take this 56 bytes and now we will overwrite the RPP. This is ridiculous. I don't know why it's doing this. Okay, sent around 56 bytes, and now as you can see we changed the RPP. Let's now go ahead and change the return address. With 56 it needs more 8. Okay, so basically here we need around 66 bytes, 64 bytes. So we take 64 bytes and let's change, come on, yeah, let's change this. And now as you can see we have successfully overwritten the return address. Anyway, you are getting the flag all the time. Now what's another way of doing the challenge? It's through the Python script, and this is the intended way of doing the challenge. So ls nano wrapper. So here, after we have successfully analyzed the binary and how many bytes it needs to crash, we will need to fill this with, the payload needs to be around, let's go back, it needs to be 48 bytes. 48 bytes literally to fill the buffer, the alignment, and the target, up until the targets. So 48. Save this, and we're going to say Python wrapper run. As you can see, we made the connection, we retrieved the flag, and we close the connection. Now, have we sent less than 48 bytes? We didn't have received the flag. Let's say we filled only the buffer. Run the wrapper. As you can see, you will receive errors, because you only filled the buffer, so you have to send the correct number of bytes. Now normally, if you are interacting with a binary, you're not gonna have this guided analysis. You're gonna have to do it all with GTP here. So you generate pattern, and then you take a look, and then you run, and you take a look at the code and the stack along with the registers. But because the program doesn't do anything, it just runs and exits. So guys, that was it. Yeah, about installing pawn tools. So you're gonna issue this command. So apt python -m and install. Let me show you, it was here, I guess. I don't want to take ages to write the command. Okay, that's it. So with Python 3 -m and install pawn, because pawn is an external package. You're gonna have to, if you're running the latest version of Debian, you're gonna have to use break system packages to be able to install pawn. But without this, it's gonna complain and not allow you to install because it's an external package. So guys, that was it. I hope you enjoyed the video, and I'm gonna see you later. And before I go, here I outlined the steps you need to take if you want to exploit buffer overflow, depending on the status of the binary, with a little bit of basics. Let's start with the basics, and then if the binary is protected with if there is LX enabled on the binary, and then it walks you through if the binary has, if it doesn't have ACLR and NS protections. Here, using pawn debug, different tools to exploit buffer overflow. You can find them in a channel subscription if you are subscribed to the tier 2. So that was it, guys. I'm gonna see you later.